How to quickly multiply two numbers using the double-halve technique. Let's say you want to multiply 35 with 18. Now most of us will probably need a calculator or need some time to do the manual calculation. But if I ask you to multiply 70 with 9, you can probably give me the answer within a few seconds. What if I tell you that 35 times 18 is exactly the same as 70 times 9? How do I know? The double of 35 is 70 and half of 18 is 9. And when you double a number and half the other, it's equivalent to multiplying by 1. And everyone knows that when you multiply by 1, the product doesn't change. So just multiply 7 with 9, that's 63, and with the 0, it's 630. That's it. 35 times 18 is also 630. Let's try another one. 22 times 45. Now if you double and half in this order, you get 44 times 22 and half, which is actually even worse, right? So instead, let's double the 45 and half the 22. And that gives us an easy 990. Now when we halve the odd number 45, we got a non-integer value. But when we double the number ending in 5, 45, we get a nice multiple of 10. And it's much easier to multiply by a multiple of 10. In fact, this technique may be worth it only if you have a number ending in 5 and an even number. If you want to practice one more, what about 55 times 12? You can put your answers in the comments if you'd like to. Next is double for division. Let's say you want to divide any random number such as 1, 2, 3 by 5. When we multiply two numbers, we could double one and half the other, but when we divide, we must do the same operation on the numerator and the denominator. So we can double both, that's 246 over 10. That's simply 24.6, because when you divide by 10, you just move the decimal one place to the left. Now when you divide the same number by 25, doubling once is not enough to give you a power of 10. That's 246 over 50. 50 is not a power of 10, so let's double again. That's 492 over 100, which is simply 4.92. As I said before, when you divide by a power of 10, move the decimal places to the left equal to the number of zeros after 1. Let me give you one more to solve. What about 29 over 125? I'll give you a hint though. When we divided by 5, we doubled once, but when we divided by 25, we doubled twice. Think about what the divisor or the denominator has to do with the number of times we double. Feel free to pause the video and work on this. If you're still unsure, I can elaborate. In the first example, our divisor was one single 5. So we doubled only once to get a power of 10. In the second example, we have two 5s. 25 is 5 squared. So we needed to multiply by two 2's or double twice to get a power of 10. And in this example, we are dividing by 3 5's or 5 cubed. So we need to double 3 times to get a power of 10 in the denominator. And as you know, it's much easier to divide by a power of 10. By the way, this double technique is useful not only for division, but also for solving very complex GMAT and GRE questions, such as this one. And I made a separate video with this example and the details of the mechanism of how we can take advantage of the double technique to solve more complex problems like this one. And the link to this video will be in the description below. And like before, feel free to put your answers in the comments below. Thank you for watching.